Good Lord, ride all the way.
10,
9,
8,
7,
6,
5,
4,
3,
2,
1.
Hello and welcome to our live broadcast of May's just past first quarter moon, or as some refer to it, the half moon. You can see the all sky camera that hasn't updated actually from last night, but we had to close because of clouds a little bit earlier. But the moon, you know, is bright enough to be able to get through those clouds. So we have just enabled the half-meter telescope. So we'll see some live images, but they might get a bit cloud affected. Anyway, welcome to our new members who joined us since our transit of Mercury broadcast last week. We've been treated to some absolutely terrific live missions this week. So I hope you've been collecting some great images. Now, if you're around at the end of Canary Islands Observatory missions, make sure you catch some of the special missions that we've been scheduling for this year's Best Cometary Hope, really, C2013 X1 Pan-STARRS. It's a gorgeous green colour and is sporting two quite distinct tails. Slooh members were among the first to spot its unexpected outburst in January before it disappeared behind the sun, but it's now back up in the pre-dawn hours, so keep your eyes open for that. If you haven't already set up your own missions to control the telescopes, check out the how-to quick start videos in the members clubhouse, and it'll show you how to do that. And if you've got any problems, then just email support@slooh.com and they'll answer your questions. Now, we love comments, but one thing that is guaranteed to spoil the view of those fascinating faint objects is a moonlit sky. But instead of cursing the moon, as an amateur astronomer and Slooh member, come to embrace it and maybe set up some moon missions to take a closer look at our nearest celestial neighbour, and maybe try your hand at some of the lunar activities you can do with the Slooh telescopes. And it's the moon that we're talking about tonight. Now, when's that from? Yeah, that's from a couple of nights ago. We are going to get the live images coming in fairly soon, so keep your eyes peeled for those. So what is the first quarter moon that occurred on Friday? Why does the moon even have phases? And why is this particular phase of the moon so interesting to look at? We're going to be answering all of these and other lunar questions, as well as taking a look at the moon from a cultural perspective. And we'll be taking a tour of some of the most interesting lunar features you can see this week. Now, if you want to ask myself or Slooh astronomer Bob Berman any moon-related questions, you can do so in the chat, which is on the live show page, which is probably where you're watching this. So to help me do all of that, let's welcome Slooh astronomer Bob Berman to the show. Hi, Bob.
Oh, great to be here.
It's always good to see you. Now, before we talk about the moon, what did you make of the transit of Mercury event last week? We saw those simply jaw-dropping images coming in from Slooh's partner Matt Francis, director of the Prescott Observatory. What did you make of those?
I thought it couldn't be better. You know, I shouldn't be spending time tooting Slooh's horn, but man, did you do a great job, Paul. You hosted that whole show. Trish with her mythology, the views from the various observatories, and Prescott Observatory, which is what we're looking at, the image you're showing here of the transit, capped it all off. I thought it could not have been better. It was a spectacle. Man, I loved every minute.
It was absolutely fabulous. And, you know, all of our partners worked really hard for that. So, but anyway, back to the moon. Now, first quarter moon was actually on Friday, but we're still in these ideal phases that are among the best for observers. So why do you prefer to observe the moon at these phases when it may seem intuitive that a full moon would be the best time to view it, Bob?
Well, you're so right. A full moon is the one that has all of the cachet. It has the fame. Those are the ones that are named, the ones that are associated correctly or incorrectly with lunacy, birth, crime. Nobody associates a gibbous moon or a half moon or a crescent moon with anything.
Yeah.
So it gets short shrift. Plus, the full moon is round, and to the ancient Greeks and other cultures, the circle was the perfect shape because it's beginningless and endless. Its circumference doesn't have a starting or ending point. And so and it's out all night long. It's the only phase that's out all night long, and it's bright. You know, you'd think the full moon would be twice as bright as a half moon, right? No, it's 10 times brighter than a half moon. So it's very special. And yet, as you just said, the half moon, and within a few days of the half moon, especially from one day before to about 3 days after, is the best time to point a telescope at it. So I'm so glad we're doing that tonight.
Yeah, and there is the first live image coming in from the half-meter telescope, and there we see it. You know, thankfully that hasn't been affected too badly by the clouds, but we can see here it's just past first quarter. Now, Bob, I said at the beginning, it's sometimes called the half moon. Which is correct?
Well, only in astronomy does half and quarter mean the same thing. It's the only science where the two are synonymous. It's a quarter moon for the same reason that on first base, the batter has reached a quarter of the way around all of the bases. It's 1/4 of its orbit from when it starts out at new moon to when it finishes up at new moon. And it's a half moon because it looks like it's half a moon, exactly half lit up.
Half a disk.
So both of them are equally correct.
Yeah. So can you let's take a step back, and can you step us through the terminology which is used to describe lunar phases? You know, so starting with new moon, we never actually see a new moon, do we? Unless it's a solar eclipse, but
correct.
We
for
refer
two reasons.
to a new moon.
One, we're looking at the dark hemisphere of the moon. People still sometimes mistake it and say that there's a far side to the moon. There isn't. I mean, there is a far side. There is no permanent dark side, no permanent dark side. Yeah. Rather, we're seeing the temporary dark side, the night side of the moon. And so we wouldn't see it. And secondly, it's in line with the sun, more or less. Most months there's not an eclipse. So it's just above or just below, but near the sun. So for a double whammy, we don't see it, and usually don't see it for a day before or after the new moon either.
Yeah, I mean, you have to keep an eye open, don't you, just after sunset for that really early moon. But actually next month, we're going to be trying something a little bit different, because we've been doing some experiments with the half-meter telescope, and would you believe we can get a view like this during the daytime, using a very special filter. So we're going to go, Bob, for an incredibly young moon, even when the sun is still up in the sky. But anyway, so back to the terminology. We start off with a new moon. What comes next? What's after a new moon?
And then we get a very thin crescent. Crescent, of course, like croissant, the French pastry, is that banana-shaped. Well, everybody knows what a crescent is. Why am I talking down to everybody? No need to dumb this down. But a crescent can be a little as thin as a hair. It can be really, really thin, and then it's very magical. And at that time, typically, we get a lot of earth shine. In other words, the dark side of the moon is glowing because of Earth almost being full at that time, and the lunar sky lights up the dark side of the moon. That's a famous feature of the thin crescent. Then night after night, the moon moves to the upper left relative to your western horizon, gets a fatter and fatter crescent, and typically 7 or so days after the crescent moon, that's when we reach the first quarter or half moon that you were just showing everybody that happened on Friday the 13th.
So what about these two bits of terminology that we often hear, waning and waxing? What do those refer to when it comes to lunar phase?
That's right. As Shakespeare said, you know, waxing, he used that periodically. Waxing means growing, and we like that in relationships as well. And waning is shrinking. So for the first 14 and a half, 15 days of the moon's cycle, again, 0 is when it's a new moon, when you can't see it. It's waxing, it's growing larger, and the full moon ends that, because you can't get any bigger than full. And so after that, you've got to get into the waning, and then everything is reversed, except not exactly, because the sunlight is lighting up the lunar features from the other side, and that's making things look a little different, just as your home might look a little different in the early morning light and in the late afternoon light, coming in from another angle. It's very special.
So we come from new moon through to a waxing crescent, through to first quarter, and then we're through into waxing gibbous moon. Is that right,
Gibbous.
Bob?
Yes, and
So
gibbous
that's
is the
what we're seeing
one
tonight,
phase
isn't it?
that people don't know. Everybody can recognize a half or a full or a crescent, but look at the moon that we're looking at right now, a couple of days after the first quarter moon. It's a gibbous moon, and if you ask most people, what is that phase called, they don't know. It comes from an Old English word meaning protruding, kind of like a beer
I was
belly.
going to ask you.
Anything protruding like that is gibbous. And
Okay.
that's
So
where that comes
you've
from.
answered.
But it can be anything. It really varies. I mean, the half moon is a half moon. Full moon is a full moon. But a gibbous moon can be anything from slightly fatter than half to virtually full, just a little bit off out of round. So it can be kind of football shaped, or quite a range. And I might add that these are all great times to observe it telescopically, as we're going to see tonight. The gibbous phase, either waning or waxing, are really great for pointing a telescope to.
We'll talk about some of the key features in a minute, but I wanted to just give you an observation of mine that I'm often surprised about, even now, and that is even after or just before, a few hours before the actual moment of a full moon, I'm always surprised at just how much relief, and you start seeing the Terminator appearing right on the edge, and you start seeing all of this beautiful relief and shadows. I mean, the actual moment when the moon is full, it really doesn't last very long, does it, Bob?
No, it doesn't. The Terminator, that line separating day from night, creeps along at 10 miles an hour, about the speed of a jogger. So considering the moon's rather small diameter, only 2,160 miles, means the Terminator really goes over the horizon rather quickly, and new features pop into view, and shadows form and shadows disappear. It's rather a stunning and dynamic and animated series of events. The moon is not at all the static, dead thing that some people imagine it to be.
Yeah, I mean, we've already said really that that full moon isn't the best time to observe it, but actually, if you get an opportunity to use a high magnification telescope and you go on to that edge, a few hours before or after, then you start seeing some fabulous detail. Now, what are the key features that moon watchers can identify? So not the actual named ones, but for instance, what are these dark patches that we're seeing in this live shot, Bob?
Yes, now that's the first thing. That's the thing that we see without any kind of binoculars or telescope. When we look at the moon, we see the dark blotches, and they're most easily seen at the full moon. But look at tonight; they're very clear. There are areas of solidified lava. But the older people didn't know that. Even Galileo with his telescope still thought that they were seas, thought they were oceans. And so for Latin, the word is mare or maria in the plural. And so we still call them seas. The odd thing is the terminology or nomenclature. All the maria, those dark blotches, are either named for weather phenomena. For example, tonight we'll be able to see the Sea of Clouds and the Sea of Rain, the Ocean of Rain, or they're named for emotions, hence the famous Sea of Tranquility and Sea of Serenity. And that very round dark blotch on the upper right, that's Mare Crisium, the Sea of Crises. So if you're going through an emotional crisis, this fits right in. This is a thing to bring to your therapist. So the moon is this.
Who named all of those, Bob?
I'm sorry?
Sorry, who named all of those? Who was?
Yeah, they've come from. I think it was the Italian observer Riccioldi. I know I'm mispronouncing his name, but I believe he gave most of the features, the names in terms of the Maria, the dark blotches, the seas. But it's so odd. It's the only place really in the universe where we have this kind of inconsistency, where we do have a pattern, but they're named for two very different things, either emotions or weather phenomena, and nothing else.
And I had seen the names, but I'd never put two and two together like that. So those are the very largest features. Now in this shot, even on this kind of fairly wide angle view, this full lunar disk view, we can make out the feature that most people know about, craters. And you know, the moon is peppered with what, 4.5 billion years worth of impacts. But we can also see on some of these craters, or in some areas, these large white areas, and a lot of those seem to emanate from some of the craters, Bob. So what are those?
Yes, where material has been thrown up by a meteor impact, the most famous being Tycho on the bottom. You see some of the white rays near the bottom of our image, the south side of the moon. They're all streaking away from Tycho. And on the upper left, there are a few less pronounced streaks. We'll see it better tomorrow night and the night after, coming away from Copernicus. Those are two of the main areas that have rays coming from. We also see them coming from Aristarchus, even further to the left on the moon, or east on the moon. Those are places of emanations. And the craters also, the bottom of the picture, you see tons of craters. Yeah. Yet within those dark blotches, the mare, there are almost none. And so this is telling you about the history of the moon. Obviously, meteor impacts must have been pretty random in hitting the moon. So if you have a lot on the bottom and you have none in the dark areas, that could not have been a random occurrence. So this tells us that something must have covered up the craters that were once there near the middle, or just above the middle of the moon. And those were lava seas spreading and drowning them out. Now, there are a few craters, rare, but there's a few within those lava seas, within those dark blotches, and that tells us those are the youngest features on the entire moon. In other words, without being an expert, without being an astronaut, without having to go there at all, just by using the Slooh telescope tonight and looking at the moon, we can figure out the moon's history, its storyline, starting from the oldest terrain, which has to be the bottom or south side of the moon, because that's where there's still lots of craters that haven't been washed out by any kind of lunar phenomena. Then you have those dark blotches. Those are intermediate ages, although they happened long ago, that wiped out what was underneath them. And then finally, the rare craters on top of those have to be brand new, the newest features on the moon. So there it is, the history of the moon right in front of us.
Visual history, how fabulous. Now, you're going to come back in 5 minutes' time, Bob, to point out some of the most interesting features that members can see over the coming nights. But right now, we're going to take a short commercial break. And when we come back, our cultural and mythology correspondent, Tricia Ennis, she's going to be talking about the significance of lunar phases culturally. But first, I want to tell you about some great shows we've got coming up this week. First, Saturday night marks the full flower moon, apparently. Not only is... Yeah, it is. Not only is it the full moon, it's also the seasonal blue moon. Now, we're teaming up with our friends at the Old Farmer's Almanac to talk about where the moon got its name and what exactly makes it a blue moon. That's Saturday at 8 p.m. Eastern. Then on Sunday at 8 p.m., the planet Mars reaches opposition. Oh, we're looking forward to that show. We are going to be taking a look at the red planet through our Slooh telescopes and talk about the history of that planet. Now, don't go anywhere. Tricia's coming on just after this commercial break. We'll see you very soon.
Hello, and thank you for joining us here on Slooh. My name is Tricia Ennis, and I am the mythology expert and cultural correspondent of sorts here. As you probably already know, there is a lot of myth and legend surrounding the full moon. Everyone knows about the strange happenings said to occur around the full moon, from werewolves and the origins of the term lunatic or lunacy. These things can all be traced back to the eerie full moon. But tonight is not about the full moon. Tonight is about the first quarter moon, the half moon. So I am here to tell you all about how different cultures, from the ancient to the more modern neo-pagan religions, see and understand the phases of the moon. The changing shape of the moon is probably one of the first night sky objects that we really come to start to understand when we're pondering the night sky as children. We learn the names, or we make them up, from the crescent moon to the half moon to the full or new moon and even the gibbous moon, which is probably my favorite because of its weird name. What's interesting is that the moon was also one of the first objects to be really understood by humans as a species. We don't actually know when mankind first figured out why their nightly neighbor changed shape the way that it did, but we do know that by the time Ptolemy, the ancient astronomer, wrote down his observations, humans already understood the moon's orbit and what caused the different phases. But just because we understand why the moon changes and how its orbit works, that doesn't necessarily mean that everyone agrees about what kind of effect it has on our lives. Many cultures throughout history have had many different opinions on the significance of the changeable moon, from the Egyptians to the Greeks to the Babylonians and to modern cultures. At this point, though, we're going to focus on one group in particular, that of Western paganism. Now, for many of these cultures and others, the moon has always been very female. The Greeks had 3 different goddesses that represented the moon, from Artemis to Selene to Hecate. The lunar cycles are understandably representative of a woman's menstrual cycle because they follow a similar schedule. So in pagan religions, like modern Wicca, where the central deity is a female figure, it's not surprising that the moon would then have special significance. Actually, the inherent femaleness of the moon is almost secondary to its significance for those whose religious beliefs revolve around the connectedness of the natural world. We know scientifically that the moon directly affects the pull of ocean tides, but some pagan practitioners take it a step further. They believe that the moon actually has an effect on the metaphysical world as well as the physical. Much like the agrarian cultures marked harvests by the appearance of the full moon, pagans believe that the different phases of the moon marked the proper time to take certain actions. The waxing moon, for example, marks a time of creativity, growth, and learning. It's a time to make positive changes in life. The waning moon represents the opposite. It's a time to make space and to shed negative influences on your life and your spirit. The cyclical nature of the moon from each phase onward in an endless cycle, those changes are also represent to some the circle of life, death, and rebirth. It's an essential principle of many pagan faiths. Let's return for a moment to Wicca, one of the most widely practiced pagan religions, especially nowadays, where the central goddess figure is actually represented in 3 specific forms: the maiden, the mother, and the crone. These 3 signify the stages of life: birth and childhood for the maiden, adulthood for the mother, and old age or death for the crone. They're also represented by the triple moon or triple crescent, which is a symbol or a talisman that uses the phases of the moon as representations of those 3 figures. The waxing moon for the maiden, representing birth and life, the full moon for the mother, adulthood, and the waning moon to represent decline, old age, and death. Each of these phases follows the other, birth to life, to death, to rebirth, in a never-ending cycle. And now that we know a little more about the cultural significance of the phases of the moon, I'm actually going to take a step back and send it right back on over to Paul Cox, who will have more on the first quarter moon.
Now here we are, still looking at this half-meter telescope view. We have to put some very special filters on that telescope because it's so big. The moon is so bright, it kind of overwhelms a really sensitive camera that we've got. Now, we're going to zoom in, hopefully, on one of these images, but members out there, please make sure you snap some of these images because these are high-resolution images, and that means that when you download them yourself, you can zoom in, and you'll see just the incredible detail that these phases of the moon give us, and as we've said, it's these lesser phases of the moon that give us these rich shadows and contrast, especially along the terminator. It really does, to me, it brings the moon to life. Is instead of kind of looking like that flat disk of a full moon, the depth and the three-dimensional features come alive. Now, let's welcome back to astronomer Bob Burmer to hear about some of his favourite lunar features that he can recommend that you can see this week. Hi, Bob.
Hi, Paul.
So here we are. We've zoomed in a little bit here. What have you got? Any kind of favourite lunar features that you keep a particular eye open for during these latter phases of the moon?
Oh, absolutely. Starting with the mountain range that you see on the upper left. There's a curving, very clear mountain range, the only one that's visible. Those are the lunar Apennines, the best mountains on the moon. The highest mountains on the moon are about as tall as the highest mountains on Earth, the Himalayas, and they just stand straight up at you. But now follow it downward. It curves down and to the left, and notice that the mountain range stops at a very distinct crater that's half bathed in shadow. Yes. This is Eratosthenes. It's a wonderful crater that is now on our left side, Eratosthenes. Yes. And then if you continue that line, again, those mountains on the upper left, this is a beautiful shot, by the way. Mountains on the upper left, go to Eratosthenes, and then to a larger crater, which is Copernicus, the famous Copernicus, just now emerging from the dark side of the moon, from the terminator. It's just coming into light. Notice it's still swallowed almost in shade. Its mountains all surrounding it are 11,000 feet high. In other words, Rocky Mountain class. The crater itself is about 55 miles from side to side, which is so wide that if you stood in the middle of Copernicus, believe it or not, you would not be able to see those mountains. The curved horizon on the moon is so sharp that the mountains that ring that crater would be over the horizon. So you'd be there on a very flat floor. There are two big and one small mountain in the center of Copernicus that'll be stunning tomorrow night as the sun rises a little higher in that area. But never mind that. Copernicus is beautiful. Eratosthenes, again to its upper right, between it and the lunar Apennines. And Eratosthenes was the librarian at the Library of Alexandria, and he was the guy who first told us the size of Earth. He figured it out mathematically without setting foot outside of Egypt. Can you imagine that? Just doing mathematically and measuring shadows and things like that. So we've got to salute him, and here we do by giving his name to that feature. Finally, the lunar Apennines, that mountain range, notice it terminates. It kind of just comes to an end at this giant, flat, dark blob, which is the Sea of Serenity. And we can feel serene identifying that. To its right, touching it like an hourglass, tangent to it, is the famous Sea of Tranquility, where, of course, the first astronauts set foot on the moon on July 20th, 1969. There's the Sea of Tranquility. So that's a good start. And all from just making your way from that most conspicuous mountain range, the lunar Apennines.
So actually, I think most of the Apollo landings were kind of in that top right area, weren't they, Bob?
Yes, quite so, because we were looking for safety, especially in the first missions, and safety meant something smooth, as it was. Neil Armstrong came across a boulder field that he had to navigate around, but we wanted to avoid the lunar highlands and those very rugged, pockmarked areas in the southern part of the moon. So all of the lunar landings were between the dead center of the moon and halfway to the edge, to the limb, and quite right. The first and the last, by the way, landers were both in that area just to the upper right of this picture. Also, the Sea of Crisis, just mostly buried by our Tweet with Us sign on the screen, but that's under there too. That's a nice view of the entire moon now. Notice how very, very cratered is the south or bottom side of the moon. Notice the rays that are all streaming away from that deep crater Tycho. And then as you follow the terminator up from there, before you get to where the lunar Apennines are, first you get to a half-hidden blotch that's half in sunlight, half in darkness. We only see the sunlit half, and that's Mare Nubrium, the sea of clouds. Again, more weather phenomena. And then proceeding up, we see Eratosthenes. And I can't even, in this lower power view, I can't quite make out Copernicus, but it's just, the sun is just rising over Copernicus. You can also see one more feature, and then I know I could just blab on and on and on. I don't want to hog everything here. But notice that the mountain range that we see, yes, now we're seeing it beautifully in this higher magnification shot, curves around a dark area, the upper left of our picture, and that is Mare Imbrium itself. And the crater that we see on the top of that is Plato. He's retaining our ancient Greek flavor here, marks the upper part of the mountains that pretty much ring. You don't have mountains surrounding all of those mares or seas on the moon, but you do in this case. And so there's Plato on the top, Eratosthenes on the bottom of Mare Imbrium. So that's very cool too. And notice there's several pockmarked craters that have landed within the smooth mare here, which shows that these are new craters. One more thing we could do is compare those new craters with the craters at the bottom, which are the ancient, almost 4.5 billion year old craters, to see if there's any difference, because that would tell us if there's any weathering on the moon. Certainly on Earth, if you looked at a feature that was 4 billion years old and compared that to a modern geological feature, there'd be no comparison, namely because there wouldn't even be any features from 4 billion years ago. They would have all been erased by wind and water and erosion. And the fact that the craters that are new, that just as observers we can tell are new because they're on top of the lava, look no different from the craters at the bottom, tell us that nothing changes on the moon. Therefore, there can't be wind and water and erosion and rain. And so look at all we have learned just from this Slooh telescope view. We have just recounted the storyline on the moon just by looking at it.
Yeah. Now we're talking at the moment, Bob, about doing a whole series of shows about the moon, maybe a series of 6 or 8. Those are going to be fascinating because there's just so much. It's a bit like Jupiter. In fact, we're going to do the same for Jupiter because there's just so much to talk about with our moon that it's always impossible to squeeze it into one show. It never does it really justice. By the way, you're not Bear Vasquez, if anybody's looking at the screen. Bob Berman is not the double rainbow guy. Anyway, these images, they do look absolutely fabulous. And I really do recommend and I do this quite often actually, I do download, snap my own lunar images with the 0.5 meter telescope, and I just go full screen and I zoom in and I just pan around. And it is like you're flying over in 3D. And these phases, you can see by the amount of detail that these shadows bring out, the contrast. It's an absolutely perfect time. So, make the most of this week during these phases in the build-up to next week's full moon show, which is a blue moon, isn't it, Bob? What makes a blue moon? Remind us.
Well, the word did not exist 100 years ago, except when you maybe tell your teenage daughter, come on, clean up your room. You only do it once in a blue moon, which meant very, very rarely. And then a Maine almanac started every year printing out that the definition of, they had a new definition that no one else used, that a blue moon, they defined it as the third full moon in a season that has 4 of them. Now, on average, a season will have only 3 full moons, but once in a while you'll get 4. And if you do, the third of the 4th would be the full moon. That's the one coming up during our show on the 21st. However, an astronomy magazine, not the big high circulation, better one, Astronomy Magazine, but their competitor, managed to get it wrong. A writer wrote about that Maine almanac and they misinterpreted it and said, well, a blue moon is sometimes called the second full moon within a month, which happens once every 2.5 years. At the very end of the month, you'll get a second full moon. And that started to be used as the definition of a blue moon. So that takes us full circle to, we're sitting here today and saying, what is a blue moon? Well, you have your choice. You can use the mistaken one, which is the more common and popular one these days, of a second full moon in the same month. That won't be happening this next full moon, or you can use the one from that Maine almanac from the 1920s, which is, and that will be happening this this coming Saturday, of the third of 4 full moons in 1 month. But either way, the moon, of course, doesn't turn blue.
I mean, we don't mind. We'll celebrate for any reason here at Slooh,
anything,
Bob?
yeah,
you know, absolutely any mean.
Good as
any mean. And I'm really looking forward to this series of shows where we can delve into these subjects, you know, a little bit deeper. So it doesn't matter whether you're interested in either the formation of the moon, or the history of the moon, or the culture around the moon, the science behind the moon, the Apollo landings, or any of those things. We'll have an episode dealing with each one of those. Now, Bob, you've got 2 live shows coming up Tuesday and Thursday, haven't you? Do you know what you've got lined up for members for those?
Yeah, we're going to be looking at galaxies, interesting galaxies. And because they're not all equally interesting, but the ones we look at will have something special about each. And on this first show, also, one of my favorite globular clusters, a city of suns, not as rich as a galaxy, but still nothing to sneeze at, the great M3. Doesn't sound like much, perhaps, but we'll zoom right in using the great Slooh telescopes.
If members check out the clubhouse, actually, if you haven't been in there yet, one of the members did some beautiful processing on M3 last week, I think the beginning of last week. So all of you members, if you haven't been in the clubhouse, then check that out and you can see some of those beautiful images. But Bob, thank you very much for joining us tonight. It's always a pleasure hearing you talk about the moon and give us your recommendations. So, and we'll see you on Tuesday.
Okay, thank you, Paul.
Thanks, Bob. That was Slooh astronomer Bob Berman, the walking, talking astronomical encyclopedia. Now, we often neglect the moon when it comes to imaging it with Slooh's telescopes, but we get to see the moon in unprecedented detail in some of the high-definition images. You know, but if you're a bit of a lunatic, no offense, there are a few moon activities that you can do with Slooh, and none of them have to do with pants and the back seat of a bus. The most basic is to make a collection of lunar phase images throughout a lunar month. Use the same telescope throughout, so you can compare the images easily. And you could even make those into a photo montage with all of the phases next to each other. And if you really want to take it further, then why not turn that series of images into a time-lapse animation? Now, we provide some free software in the clubhouse and provide a quick video tutorial that shows you how to use it, not just for the moon, but also for creating animations of Jupiter and its moons. It's also a technique, actually, that's used in the Discovering Pluto activity. So if you are a new member and you think, oh, what should I do with the telescopes tonight? Then have a look at some of those activities and you're sure to get some inspiration. You can also collect full moon images over several months, and you'll then see its apparent size change as it moves from perigee, when it's closest to Earth in its elliptical orbit, to apogee, when it's furthest away from Earth. Those two look great if you create an image montage. So if you are comparing 2 images from the same telescope and you think, hey, they've changed how much it's zoomed in. No, we haven't changed it at all. That's fixed. The moon is either slightly further away or slightly closer to us when those images were taken. But they make a fabulous, fabulous image montage or time-lapse animation. Now, if members don't do it, this has been something that's been on my to-do list for a very long time now. So I'm going to probably do that. The T2 Wide Field Telescope is a pretty good one for any of those, because you're guaranteed to get the full disk of the moon in there. Now, don't forget, there are loads of activities in the clubhouse that you can do. Just hop along to the how-to page. It's on the top menu, how-to in the clubhouse. Scroll down and you'll see a whole list in categories: starter activities and advanced and intermediate and all sorts of stuff like that. Well, anyway, look, we're still watching. Whether the clouds have been kind. We will probably have to close up again. That the moon is bright enough and strong enough to get through some light cloud, but obviously faint galaxies and nebulae, they're not strong enough to get through the clouds, so we may have to close. I'll check the weather in a sec. But that's about it for tonight. But we have got plenty to keep you entertained this week. You've heard already that Bob's got his 2 shows on. But we have Eric Edelman is back from his hiatus. On Tuesday night at 9 p.m, Eric will join us to talk about the recent announcement from the Kepler Space Telescope mission about the 1,000 or so new exoplanets that they've discovered and what that means for our ongoing search for alien life. Now, if you missed our interview with Lisa during the Transit of Mercury show, all about exoplanets, you should go back and have a look at that. You know, these are groundbreaking times that we're living in as far as the discovery of life around other planets, or maybe even some of the bodies in our own solar system. Now, Saturday night marks the full flower moon. Well, I'm going to have to say that I shall stay off the wine for the full flower moon on Saturday night. Not only is it full moon, but it's also that seasonal blue moon, as Bob described. We're teaming up with our friends at the Old Farmer's Almanac to talk about where the moon got its name and what exactly makes it a blue moon. That's Saturday at 8 p.m. Eastern. Then on Saturday at 8 p.m, Sunday at 8, the planet Mars reaches opposition. Opposition is when it's closest and best viewed from Earth. We'll take a look at the red planet through our Slooh telescopes and talk about the history of that planet. Now, if you are out in your own backyards, probably after midnight, look south if you're in the Northern Hemisphere, and you'll see 3 very bright objects, and they all have quite a red colour to them. And one of those is Mars, the brightest is Mars, and then you've got Saturn there, and then you've got Antares, the heart of the Scorpion in the constellation of Scorpius. So check those out. It's a beautiful sight from your own backyard. Now, if you haven't checked out the Clubhouse recently, pop along and take a look at David Mihalak's astonishing image of the Lagoon Nebula. Absolutely stunning. It's currently on my laptop desktop, so make sure you go along and have a look at that. It's an absolutely stunning image. So thank you, David, for sharing that one. We will see you all again soon as we watch this live image of the just past first quarter moon from the half-meter telescope. Don't forget, download those snaps and zoom in full screen on those, and you'll be in for a lovely, lovely surprise at the amount of detail that you can see. We'll see you very shortly, but for now, it's goodbye from me, and goodbye from Bob Berman, and goodbye from Trisha Ennis in the studio. So good night.